Hi everyone, welcome to your third week of online learning. Today we are going to do the following. So I can replace a variable with a number. I can use substitution to find the value of an expression. Okay, so let's start right now.
Jeez. The kids don't need to see that. All right, so with substitution, we have done substitution before, we just haven't termed it as such. So when we were doing all of our volume formulas and our area formulas, that's really just substituting in values for unknown variables. Okay. However, we haven't really done anything that's looked specifically like this. So for addition, let's say I have x equal to 6. Okay. If I have the expression x plus 3, all I really have to do is just take the number and substitute it in for the variable. So if I take this, I'm going to actually end up with 6 plus 3. Okay, and 6 plus 3 would be 9. Okay, so the value of this expression after I've substituted x equal to 6 in would be 9. Okay, so it doesn't matter where the variable is in my expression. Okay, we treat it the exact same. So in this expression, instead of x plus 3 in the last one, we have 3 plus x. So in this case, I start by substituting my 6 in for x. So I would have 3 plus 6. Okay, so then 3 plus 6 gives me 9. Okay, these ones were fairly simple because we had x equal to a positive number. However, what if I had x equal to a negative number? Okay, this is where we need to start remembering our adding and subtracting integer rules. Okay, so let's start by substituting our value in for the x. So in this case, I would have minus 6 plus 3. Okay, so here we have to remember what happens when I add a positive number to a negative number. So if I have a number line, okay, I'm going to start at minus 6. Okay, so if I'm going to add a positive, here's where you guys are going to come in. Am I going this way or that way? In fact, if I'm adding a positive number, I go this way. So if I have minus 6 and I am adding 3, okay, I would go 1, 2, 3. I would end up with negative 3. So my answer to this one would be negative 3. Okay. So what if we had 3 plus x in this case? Okay, so we start by substituting our value in. Okay, so 3 plus a negative 6. So instead of thinking about this in terms of a number line, this time we're going to think about it in terms of integer chips. Okay, so I start with 3 positive integer chips. Okay, now I'm going to add 6 negative chips. 1, 2, 3, 4, 5, 6. Okay, so now we have to look and see, do I have any zero pairs? I sure do. I have 1, 2, 3. So what is left? And up here I have minus 3. So in this case, I also have minus 3. Mr. Manoog's giving me the thumbs up. Okay, what if I had subtraction? Okay, so subtraction is very similar to addition. We still have to remember our adding and subtracting rules. Okay, but we treat it the same way, only my operator is different. So if x is equal to 3, in this case, I have 3 minus 5, okay, which in this case will end up giving me a negative 2. Okay, what if I have it the other way? What if I have 5 minus x? Well, again, I substitute my value in, so 5 minus 3 in this case would give me 2. Okay, so if we notice, last time when we were adding, if we reversed the expression, okay, from x plus 3 to 3 plus x, we got the same number. Okay, even over here when my value was negative, we still got the same number when we reversed it. For subtraction, if I just reverse the expression, my value changes. Okay, so it's not always the exact same number if I'm just changing my expression. What if I have a negative number? Okay, so in this case, let's substitute our negative number in. Okay, so we're going to think about this one in terms of a number line. Okay, so if I have minus 3, if I'm going to subtract 5, am I going to be going this way or this way on my number line? In fact, when I subtract, if I'm subtracting a positive number, I go this way. So if I have minus 3 and I subtract 5, 1, 2, 3, 4, 5, I end up with negative 8. So in this case, I get negative 8. So for this one, okay, if I'm going to substitute my value in, which is a negative 3, so I get 5 minus a negative 3. Okay? Whenever we have the same signs here, so if I'm subtracting a negative, okay? For my 8 5s, you'll remember the slash change method. Okay, I believe Mr. Manug was saying that you could multiply a negative times a negative to give you a positive. So another way to think about 5 minus a negative 3 is 5 plus 3, okay, which in this case gives us 8. Okay. The other way that we can think about it real quick is if we do integer chips here. So if I start with 5 integer chips, okay, there's 5 integer chips. And then this, I'm going to take away 3 negative chips. So in order to do that, I have to start with 0 pairs, okay? And then I'm going to take away, the minus means take away, negative 3 chips. So if I take these chips away, what am I left with? Well, I'm left with 8 positive chips, which is why we get positive 8. Okay, over to you, Mr. Manug.
Thank you, thank you. All right, so that was for addition and subtraction. Now we are going to start with multiplication and division. But before we do that, let's just review very quickly from your integer unit. So a positive times a positive is a positive. A negative times a negative is a positive. A positive times a negative is a negative. And a negative times a positive is a negative. This is pretty much the same thing, but in this case, it is division. Okay.
One of the easier ways to think about this particular bit is if my signs are the same, I'll get a positive. If my signs are opposite, I'll get a negative, and that works for both multiplication and division.
All right, thank you. All right, let's just start with multiplication now. So we know that for multiplication, again, if there is a coefficient and a variable and there's no signs or whatever, we assume it is multiplication. So in this case, it will be 2 times 9, and that will give me 18. Same for this one. 4x is the same thing as 4 multiplied by x. In this case, x is 9, so 4 times 9, that would be 36. Again, this is easy because we're dealing with positive numbers, but if it's negative, we have to remember our integer rules, right? So 2x is 2 times negative 9. So same thing again, a positive, let me just find that one. A positive times a negative is a negative, so it'll be negative 18. This one, 4x, so it'll be 4 times negative 9. A positive times a negative is a negative. So positive times a negative is a negative, negative 36. All right, so that's it for multiplication. Now let's move on to division. Again, division, I know we are very used to seeing this, but sometimes they like to put it as a fraction. So I'll just put the signs here so you could see it. Now x over 2 is the same thing as x divided by 2, which is 36 divided by 2, and your answer should be 18. This one, x over 4 is the same thing as x divided by 4, which is 36 divided by 4, and that would be 9. Yeah, pretty straightforward. Now this one, there's a negative, so we need to be mindful of our integer rules for division. X over 2 is x divided by 2. That would be negative 36 divided by 2. A negative divided by a positive is a negative, so we know that my answer is going to be a negative for sure, and we get negative 18. Same thing for this one here, x over 4. X divided by 4, negative 36 divided by 4, a negative divided by a positive is a negative, and get a negative 9. So that is pretty much it for today's lesson. Is there anything else, Mr. Cadet, that we need to go through?
No, but we will leave you with a really good view of this, just in case you want to write it down, because I know that sometimes this might be, because this is from grade 7, so if we don't remember it, maybe we can write it down on a flashcard or something to help us out. But the big one is that we have to remember if we are, for substitution, we're replacing a variable with a number. So it's the same as when we were substituting with our area formulas, because we've done this, okay? And that we can use substitution to find the value of an expression, which is what we were doing back here, okay? So just solving some questions. Keep a lookout for the worksheet that we will be giving you and the assessment a little bit later in the week.
All right, you guys have a good day.
Everybody have a good day.
Bye.